So we're going to simplify radicals, but we're looking at more than just perfect squares today. So last week we solved using the square root method. And so we said if we had x squared and we took the square root of that, what would happen? Yeah, so the square root and the square cancel out, and we just have x left. And so that happens because they're inverses or they're opposites of each other. So what do you think would happen if I had x to the third and I took the cube root? Yeah, the same thing. So those would cancel out also. And we would just have x. Well, what do you think if we had x to the fourth and we took the fourth root? Yeah, they would cancel out also, and we would just have x. And we could keep going. We could have x to the fifth, we could have x to the sixth, we could have x to the 100th. And whenever you take that same root, they're always going to cancel because they're all inverses of each other. We'll look at those. So let's do one kind of like what we've been doing, but let's add some variables in there. So let's say we wanted to do, let's just do a square root just to review one more time. Let's say we have the square root of 12x to the fifth. Well, we're going to list them out. So the first thing we want to do is look at the number. Is 12 a perfect square? No. So we still have to break it down just like what we did for our warm-up. But what prime number goes into 12? 2. So 2 and 6. How about 6? 2 also. 2 and 3. Good. And 3 is prime. So 3 and 1. So we have a pair of 2's. So 2 is going to come outside. And then 3 all by itself, it stays inside. So the number part is no different than what we've been doing. But now we have these letters. So we have x to the fifth. So that means we're multiplying x by itself 5 times. Okay? So I'm going to list out 1, 2, 3, 4, 5 x's. Because x to the fifth. Now, just like we paired up the 2's, we're going to pair up the x's. So I've got 2 x's there, 2 x's there, and 1 x left. Everybody okay with that? Okay. So it's going to be an x times an x on the outside and 1x on the inside. Okay, so just like a pair of 2's brings out 1, 2, pair of x's brings out 1x. Questions? What's x times x? X squared. So x squared, square root of x. And now we just put it all together. So on the outside we've got a 2 and we have an x squared. So 2x squared. And then on the inside we have a 3 and we have an x. So 3x. And that's it. Any questions? So you're still pairing them up the same way. You're just bringing out variables. And you can have multiple variables. You could have x, y, z. It's not just going to be one. It could be multiple. Okay. So let's say we want to do a cube root. Let's do the cube root of 64. So you always want to check and see if it's a perfect cube. So to type a cube in your calculator, go to Math. And then if you look at that number 4, it says cube root. So Math number 4. And then we're typing in 64. And it is. So then our answer would just be 4. Okay? So just like there's perfect squares, there's perfect cubes. Okay? Questions? Go to Math, which is below the green button. Yeah. And then number 4. Okay. Alright, let's do one where it's not perfect. So let's say we have the cube root . 405. Okay. So again, first thing you want to check, let's just see if this is a perfect cube, even though I already told you it wasn't, but we'll check it anyway. So we go to Math. We go number 4. 405. No. So then we have to break it down the exact same way that we did number 1. Okay? So we start with 405. And what prime number goes into 405? 5. Good. So it ends in a 5. So remember, if it ends in a 5 or a 0, 5 always goes into it. So 5 goes in there 81 times. What prime number goes into 81? 3. How many times? 27. How about 27? What goes into that? 3 again. 9 times. Good. And then 9 is 3 and 3. And then 3's prime. So 3 and 1. Okay. So same steps. The only difference, we have a cube root, but we're still breaking it down the same. Any questions on that part? Okay. But if we look up here, we need a cube to cancel out a cube root. So we don't want a pair, we want 3 of a kind. Okay. So if I look at this, I've got 3 3's. Okay. So instead of pairing them up, now we need 3 of them, 3 them up. That's what we're doing. Okay. I don't know if that's a word, but that's what we're going to say. So when you have 3 of a kind, then one of them can come outside. Okay. So cube root, you need 3 of a kind. So everything's the same. So we're looking for 3 instead of 2. And now we still have a 5, we still have a 3. They can't partner up, so they stay inside. So cube root of 5 times 3. So then our final answer is 3 cube root of 15. Okay. And just like when we typed it in and we checked, so we did 405. We can check these as well. So 3 cube root of 15 is that same decimal. That's your answer. Questions? Okay. Let's add in some variables then. So, let's say we had the cube root. $250. x to the 6th, y to the 4th. Okay, so the first thing we check is 250 a perfect cube? So math, number 4, 250, no, it is not. So then we have to break it down. So what prime number can go into 250? Yeah, 5 or 2, either way. So I'm going to go 5. And it goes into 5 50 times. Good. What prime number goes into 50? 5 also. 10 times. How about 10? 5 again. 2 times. And what about 2? 2 is prime. So 2 and 1. Okay. So I'm looking for 3 of a kind. Do I have 3 of a kind? Yeah. 5s. If you don't have 3, then it's like the ones where if you didn't have a pair, it just stays the same. Yep. So then pair of 5, so 5 comes out, and then that little tiny 2 is all by himself, so he stays inside. Okay. But we're not done because we have these x's and we have the y's. So we have 6 x's and we have 4 y's. So I'm going to list them out. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay. So just like we need 3 5s, we need 3 x's and we need 3 y's. So I've got 3 x's here and 3 x's here. And I also have 3 y's. So I've got 2 x's that come outside and 1 y. And then this little y right here is all by itself, so he stays inside. So then if I simplify x times x, x squared y, cube root of y. Yep. So we put it all together. So we got a 5 on the outside. We've got an x squared and a y. And then on the inside, we have a 2 and a y. So same things that we've been doing, just more things to pair up. I mean, pretty much, but. Okay. Let's look at another one. Okay. Let's say we had a 4th root. Of 80. X to the 4th, y to the 10th, z squared. So in this one, it's a fourth root. So of course we want to see if 80 is a perfect fourth. So anything over 3, you have to type that number first. So I want the fourth root, so I'm going to type the 4. You always have to do that first. Then you go to math. And then you look at number 5, and it has just a little X there. So whatever you type, it'll put as your root. So we do number 5. And then it'll automatically make it a little tiny 4. And then we're looking at 80. And it's not. So then we have to break it down just like we did the last ones. So what prime number goes into 80? 2. And 2 goes in there 40 times. Good. And what prime number goes into 40? 2 as well. Good. 20 times. How about 20? 2 10 times. Good. And how about 10? 2 times. Good. And then 2's prime. So 2 and 1. So, when we had a square root, we needed 2 of a kind. When we have a cube root, we need 3 of a kind. What do you think we need when we have a fourth root? 4 of a kind. Good. Well, if I look at this, I've got 1, 2, 3, 4 2's. So all of my 2's here pair up. Okay, so square root you need 2 of a kind, cube root you need 3 of a kind, fourth root you need 4 of a kind. So then that brings out a 2, but then we still have that little 5 in there all by itself. Just whichever ones you have 4 of a kind. Yeah. It just happens to be the first one, but it doesn't have to be. Okay. Any questions on the number part? Alright, so let's look at the variables then. So we have 4 x's. We have 10 y's. And we have 2 z's. Okay. So again, we want 4 of a kind. So do I have 4 x's? Yeah. So then I got a bunch of y's, so I can count 1, 2, 3, 4 there. 1, 2, 3, 4 there. And then I don't have 4 z's, so we'll just leave them. So we've got 4 x's, so 1 x comes out. We have 2 sets of 4 y's, so 2 y's come out. But then we don't have any z's, so no z's can come out. So then left on the inside, we don't have any x's inside, but we have 2 y's, and we have 2 z's. Questions? So then we can multiply them. X, y times y is y squared. And on the inside, y times y is y squared, and z times z is z squared. So then we put them all together. So outside we have a 2, an x, and a y squared. You got it. Good. So on the inside we still have the 5, y squared, z squared. Questions? And that's about as tough as it gets. Do what? So you can't check the variable part, but you can check the number part. So we do 4th root, so you type the 4 first, and then number 5 of 80. And then you just do the number part. So 2, I think you have to do parentheses 4. Yeah. And then 5. Because if you just do 2, well, you might could do 2 times 4. Let's see. Yeah, either way. So either 2 parentheses or 2 times. And that gives you the same. You might notice any patterns in like the roots to the exponents. Yeah. But how about like if I started with a 4th root, I had x to the 4th and 1x came outside. Or I had y to the 10th, 4th root, 2 y's came outside. It's fine. We'll talk about that tomorrow. Any questions on this? And this would probably be about as hard as it'll get. You shouldn't have more than 3 variables. Alright, let's try some. Oh, probably shouldn't phrase it. Okay, so under your desks, there are